This is B. Ramarao from SRRS Government Polytechnic College, Sirsilla. Today we discuss about our topic Bronsted-Lowry acid-base theory. Bronsted-Lowry acid-base theory. Objectives. On this hour, you would be able to know about Bronsted acid, Bronsted base, Bronsted Lowry neutralization, Bronsted Lowry neutralization reactions, and limitations of Bronsted Lowry acid base theory. After the end of this period, you would be able to know about Bronsted Lowry acid base and neutralization reaction, and also understanding the Bronsted Lowry concept of acid and bases. According to Arrhenius theory, once again repeated Arrhenius theory, what is acid, what is base, what is neutralization reaction of Arrhenius acid base theory. Once again repeated substance which gives H plus ions when dissolved in water is called acid. Substance which gives H plus ions when dissolved in water is called acid. The substance completely or partially dissociated in aqueous solution, it produces H plus ions, is called acid. Like example, HCl, H2SO4, HNO3, CH3COH, H2CO3, these all are acids. Substance which gives OH minus ions when dissolved in water is called base. Substance which gives hydroxyl ions when dissolved in water is called base, like sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide, magnesium hydroxide. These all are bases, like NaOH, KOH, MgOH taken twice, AlOH taken thrice, NH4OH. These all are bases. Acid and base react together to form salt and water. Reaction is called neutralization reaction. Like HCl plus NaOH gives NaCl plus H2O. This reaction is called neutralization reaction. The reaction between acid and base to form salt and water is called neutralization reaction. The acid or base which is dissolved in completely, it produces more number of H plus ions or more number of OH minus ions in aqueous solution is called strong acid. The substance partially dissociated in aqueous solution, it produces less number of H plus ions or OH minus ions in aqueous solution is called weak acid or weak base. Weak acid and weak base. In according to Arrhenius theory, he explained only aqueous substance nature. Non-aqueous compounding character should not explain Arrhenius theory. Some metal oxides are act as bases like sodium oxide, calcium oxide, magnesium oxide. These all are bases. But it could not explain about basic nature of oxides. And also it could not explain acidic nature of some oxides like CO2, SO2, SO3, N2O5, N2O3, P2O3, P2O5. These all are acids. The H plus ion produced in aqueous solution, it forms hydronium ion in water. So those H plus ion should not present in aqueous solution. So these limitations explained by Bronsted Lowry theory. According to this concept, acids are the species capable of donating the proton in a reaction. That is, acids are proton donors. Photogenic. The substance which gives H plus ion to another substance in a reaction is called acid. Acids are the species capable of donating the proton in a reaction. That is, acids are proton donors. Proton donating capable of substance is called Bronsted-Lowry acid. Acids are the substance which gives H plus ions in aqueous solution is called acids. Like HCl, H2SO4, HNO3, CH3COH, HClO4, H2CO3. These all are acids. These substance proton donate to another compounds in a reaction is called acids. Bases are the species capable of accepting the proton in a reaction. That is, bases are proton acceptor. Bases are the species capable of accepting the proton in a reaction. That is, bases are proton acceptor. Proton acceptor or bases. Acids are the species capable to donating proton in a reaction. That is, acids are proton donor. Bases are the species capable of accepting the proton in a reaction. That is, bases are proton acceptor. Protophilic components are bases. Protophilic components are bases. HCl plus H2O gives H3O plus Cl minus. HCl acid H2O base then form H3O plus Cl minus. HCl proton donating in this reaction to water then form H3O plus Cl minus. HCl proton donate to the water in this reaction, so HCl act as acid. Same in this reaction, water molecule accept two proton from HCl molecule. So water act as proton acceptor. This proton accepting capable of substance is called Bronsted Lowry base. So in this reaction, HCl act as acid, H2O act as base. This HCl plus H2O gives rise H3O plus Cl minus. The HCl proton donate to water molecule then form Cl minus. The Cl minus act as base. Acid proton donate to another substance then form basic compound. The base of water molecule accept proton from HCl then form H3O. These H3O plus act as acid. This acid proton donate to another substance then form base. Base accept to the proton from another substance then form the compound act as acid. In this reaction, acid 1 then form base 1, base 2. Base 1 then form acid 2. Single reaction, two acids and two bases are present in Bronsted-Lowry theory. CH3COOH plus H2O gives H3O plus CH3COO minus. In this reaction, acetic acid proton donate to water molecule, so acetic acid act as Bronsted-Lowry acid. These water molecule gain a proton from acetic acid. These water molecule act as Bronsted-Lowry base. These acid of CH3COH then form CH3CO minus act as Bronsted-Lowry base. This water molecule in this reaction act as base, then gain a proton to form H3O plus act as acid. Acid, acetic acid, proton donate to the water. These acetic acid form acetate ion act as base. Water molecule in this reaction act as base. This base to form hydronium ion. This hydronium ion act as hydronium ion act as acid. The same way, CO2 plus H2O to form H3O plus HCO3 minus HCO3 minus HCO3 minus NH4 plus H2O gives H3O plus NH3. HSO4 minus plus H2O gives H3O plus SO4 minus 2. HSO4 minus plus H2O gives H3O plus SO4 minus 2. H2O can be act as CO2 plus H2CO3 gives rise H3O plus HCO3 minus HCO3 minus. In this reaction, proton donor and proton acceptor are present. One is acid, another one is base. Ammonium ion proton donate to water molecule, then ammonia act as acid, water molecule act as base. Sulfate ion donate to proton water molecule. This sulfate ion act as acid, H2O act as base. H2O can act as both as an acid as an base. H2O can act both as an acid and base. H2O is ampiprotic. H2O is ampiprotic molecule. H2O is a ampiprotic molecule. H2O gives rise OH minus. H2O gives rise OH minus. When it is acid to form OH minus, H2O acts as base to form H3O plus. H2O gives OH minus when it is act as acid. H2O base to form H3O plus. H2O act in the reaction to form H3O plus. H2O act as acid to form OH minus. So CO2 plus H2O. This CO2 to form H3O plus HCO3 minus. So NH4 plus NH3. HSO4 minus to form SO4 minus 2. So in this reaction, CO2 acid, NH4 plus acid, HSO4 minus acid. H2O can be act as both as an acid and basis. H2O is ampiprotic molecule. H2O when it is act as acid to form OH minus. H2O act as base to form H3O plus molecule. The acid and base which differ by a proton are known as conjugate acid-base pair. The acid and base which differ by a proton, which is differ by only one proton of the pair, is called conjugate acid-base pair. The acid and base which differ by a proton are known as conjugate acid-base pair. CH3COOH plus H2O gives rise H3O plus CH3COO minus. The conjugate acid-base pair differ by only one proton. Pair is called conjugate acid-base pair. The acid and base which differ by a proton are known as conjugate acid-base pair. CH3COH plus H2O gives H3O plus CH3COO minus. CH3COOH to form CH3COO minus. These acid to form base. These acid-base pairs are called conjugate acid-base pair. CH3COH, CH3CO minus. These acetic acid, acetate ion base. These differ by only one H plus ion pairs are called conjugate acid-base pair. H3O plus acid, H2O base. These acid and base differ by only one proton. Difference of these pairs are called conjugate acid-base pair. CH3COOH plus H2O gives H3O plus CH3COO minus. The above reaction involves two conjugate acid-base pairs. CH3COH acid gives rise CH3COO minus. These acid convert to base. H2O base, H3O plus acid. These acid and base pair differ by only one proton. Pairs are called conjugate acid-base pairs. Conjugate acid-base pair. CH3COH acid, CH3CO minus base. These acid and base differ by only one proton. Pairs are called conjugate acid-base pair. H2O base, H3O plus acid. These acid and base differ by only one proton. Pairs are called conjugate acid-base pair. Some example of conjugate acid-base pairs: HNO3 acid, NO3 minus base. H2SO4 acid, HSO4 minus base. H2O acid, OH minus base. CH3COH acid, CH3COO minus base. NH4 plus acid, conjugate base NH3. HCl acid, Cl minus base. NH3 acid, NH2 minus base. H3PO2 acid, H2PO2 minus conjugate base. Some example of conjugate acid-base pairs are HNO3 nitric acid. This nitric acid conjugate base NO3 minus nitrate ion. H2SO4 sulfuric acid, HSO4 minus sulfate ion conjugate base. H2O water molecule. This conjugate base hydroxyl ion. Acetic acid CH3COH, acetate ion CH3COO minus conjugate base. NH4 plus ammonium ion, NH3 ammonia conjugate base. HCl hydrochloric acid, chlorate ion conjugate base. NH3 ammonia conjugate base, NH2 minus amine ion. H3PO2 phosphate ion, H2PO2 minus conjugate base. Strength of acids: Ha plus H2O gives rise H3O plus A minus. Ha react with H2O to form H3O plus A minus. Ha acid react with water molecule to form H3O plus hydronium ion plus A minus. Therefore, Ka is equal to H3O plus A minus concentration by Ha concentration. H3O plus concentration, A concentration by Ha concentration. Ka is equal equilibrium constant of acids. Strength of acids. An acid which has greater tendency to donate a proton is called strong acid. An acid which has great tendency to donate a proton is called strong acid. An acid which has greater tendency to donate a proton is called strong acid. Like example, HCl, H2SO4, HNO3, these all are strong acid. An acid which has less tendency to donate a proton is called weak acid. CH3COH, H2CO3, HCOOH, these are weak tendency to donate a proton is called weak acids. An acid which has less tendency to donate a proton is called weak acid. An acid which has greater tendency to donate a proton is called strong acid. Strength of bases. Strength of bases. B plus H2O gives rise BH plus OH minus. B base react with water molecule to form BH plus OH minus. Therefore, Kb is equal BH plus concentration OH minus concentration by B concentration. Kb is equal BH concentration plus OH minus concentration by B concentration. Therefore, Kb is equal equilibrium constant of base. Strength of bases. A base which has more tendency to accept a proton is called strong base. A base which has more tendency to accept a proton is called strong base. Strong base. Strong base like CH3COO minus HCO3 minus COO minus, these all are strong bases. A base which has more tendency to accept a proton is called strong base. Strong base. CH3COO minus HCO3 minus COO minus, these all are strong bases. A base which has more tendency to accept a proton is called strong base. A base which has less tendency to accept a proton is called weak base. A base which has less tendency to accept a proton is called weak base. Like Cl minus, HSO4 minus, NO3 minus. A base which has less tendency to accept a proton is called weak base. A base which has more tendency to accept a proton is called strong base. A base which has less tendency to accept a proton is called weak base. Strong acids CH3COO minus HCO3 minus. Weak bases Cl minus HSO4 minus NO3 minus. Bronsted-Lowry theory. In 1923, Bronsted, a Danish chemist, and Lowry proposed new definitions of acids and bases. Bronsted-Lowry theory. Bronsted and Lowry had worked independently of each other, but they both arrived at the same definitions. Bronsted and Lowry had worked independently of each other, but they both arrived at the same definitions. An acid is a substance that donates proton. A base is a substance that accepts proton. An acid is a substance that donates proton. HCl, H2SO4, HNO3. A base is a substance that accepts proton. H2O, NH3, OH minus, Cl minus, CH3CO minus. An acid is a substance that donates proton. A base is a substance that accepts proton. HCl, acid, is equal proton donor. HCl plus H2O gives H3O plus Cl minus. HCl proton donate to water, then form Cl minus. H2O proton accept to HCl to form H3O plus. The HCl donate a proton and so an acid. The H3O plus is the case accept a proton and so it is base. Remember, proton is equal to H plus ion. HCl plus H2O gives H3O plus Cl minus. The HCl donates a proton and so is an acid. The H2O in this case accept a proton and so is a base. Like HNO3 plus H2O gives H3O plus NO3 minus. HNO3 plus H2O gives H3O plus NO3 minus. H2SO4 plus H2O gives H3O plus HSO4 minus. HNO3 plus H2O gives H3O plus NO3 minus. HNO3 donate proton to water. These HNO3 act as acid. Proton donate to form NO3 minus is act as base. H2O in this reaction base H3O plus acid. Sulfuric acid react with water molecule to form H3O plus HSO4 minus. H2O acid, H2O base, H3O plus acid, HSO4 minus base. H2O plus HSO4 minus to form H3O plus SO4 minus 2. The sulfate ion HSO4 minus react with water molecule to form H3O plus SO4 minus 2. These HSO4 minus act as acid H2O base to form H3O plus SO4 minus 2. SO4 minus 2. H2SO4 plus H2O gives H3O plus HSO4 minus. HSO4 minus react with water molecule to form H3O plus SO4 minus 2. SO4 minus 2. Base is equal proton acceptor. NH3 plus H2O gives NH4 plus OH minus. In this reaction ammonia and water molecule to form ammonium ion plus hydroxide ion. In this reaction Ammonia act as proton acceptor. Water molecule act as proton donor. Ammonia proton donate from proton accept from water molecule in this reaction. So this acceptor of proton of ammonia is act as Bronsted Lowry base. Water molecule in this reaction proton donate to ammonia. In this reaction water molecule act as Bronsted Lowry acid. Ammonia to form ammonium ion. This ammonium ion act as acid. Hydroxyl ion act as base. The ammonia accept a proton and so it is a base. It is a base. The H2O in this case donate a proton and so it is an acid. So it is an acid. Amphoteric. As can be seen from the previous two examples, water is capable of acting as both acid and as a base. Any substance that can act as both acid and base is said to be amphoteric substance. Amphoteric substance. As can be seen from the previous two examples, water is capable of acting as both an acid and base. Any substance that can act as both an acid and base is said to be amphoteric. Acid base reaction. HCl act as acid, NH3 base to form Cl minus plus NH4 plus. HCl proton donate to ammonia, so in this reaction HCl act as acid. Ammonia proton accept from HCl, this ammonia act as base. Neutralization reaction. The reaction between an acid and base to produce a salt and water. A salt is formed when the hydrogen of an acid is replaced by a metal. The reaction between an acid and a base to produce a salt and water. Acid and base react depends on transfer of proton. The reaction between acid and base by transfer of proton is called neutralization. The reaction between an acid and a base to produce a salt and water. A salt is formed when the hydrogen of an acid is replaced by a metal or ammonium ion. Ammonium ion. Neutralization. Acid and base to form salt and water. HCl react with NaOH to form NaCl plus H2. But since the acid and base dissociated in water, we can write H plus Cl minus Na plus OH minus to form Na plus Cl minus H plus OH minus. We can cancel the Na plus and Cl minus on both sides, leave H plus OH minus to form H2O. Conjugated acid-base pair. Acid and bases exist in a pair called conjugate acid-base pair. Every time an acid donates or loses a proton, it becomes its conjugate basis. Example, CH3COH plus H2O gives CH3CO minus plus H3O plus. Acid and base exist in a pair called conjugate acid-base pair. Every time an acid donates or loses a proton, it becomes its conjugate base. The acid and base differ by only one proton. Pairs are called conjugate acid-base pair. The acid and base pair differ by only one proton. Pairs are called conjugate acid-base pair. Conjugate acid-base pair. Likewise, when a base accepts a proton, it becomes its conjugate acid. It becomes its conjugate acid. NH3 base react with water to form NH4 plus OH minus. NH3 base, NH4 plus acid, H2O, acid, OH minus base. OH minus base. H2SO4 react with water molecule to form HSO4 minus H3O plus. H2SO4 acid, its conjugate base HSO4 minus, H2O base, its conjugate base H3O plus. Another one example, NH3 plus H2S to form NH4 plus HS minus. NH3 base, its conjugate acid NH4 plus, H2S acid, its conjugate base HS minus. HS minus. Summary. Acids are proton donates. Proton donors are called acids. Like example, HCl, H2SO4, HNO3. These all are acids. Bases are proton acceptor. Proton acceptor are called bases. Like example, H2O, NH3, OH minus, CH3CO minus, Cl minus. Acids are proton donors. Bases are proton acceptors. The acid and base which are differ by a proton are known as conjugate acid-base pair. The acid and base which differ by a proton are known as conjugate acid-base pair. Conjugate acid-base pair. Like conjugate acid-base pairs, HCl acid, its conjugate base Cl minus, H2SO4 acid, its conjugate base HSO4 minus, HNO3 acid, its conjugate base NO3 minus, CH3COOH acid, its conjugate base CH3COO minus, H2O acid, its conjugate base OH minus. An acid which has less tendency to donate a proton is called weak acid. An acid which has less tendency to donate a proton is called weak acids. Weak acid. Less tendency to donate a proton is called weak acid. CH3COH, H2CO3, HCOH. These all are weak acids. An acid which has greater tendency to donate a proton is called strong acid. HCl, H2SO4, HNO3. HNO3. A base which has more tendency to accept a proton is called strong base. A base which has more tendency to accept a proton is called strong base. more tendency to accept a proton, like CH3CO minus, HCO3 minus, COO minus, strong bases. A base which has less tendency to accept a proton is called weak base. Base which is Bronsted Lowry acid. CO2, SO2, NH3, HCl. Bronsted Lowry acid. Proton donor is called Bronsted Lowry acid. CO2, SO2, NH3 and HCl. HCl easily proton donate to another substance, so it is acid. Answer D. Which is Bronsted Lowry base? CO2, SO2, NH3, HCl. NH3 easily proton accept from another substance is act as Bronsted Lowry base. NH3, CO2, SO2, NH3, HCl. NH3 Bronsted Lowry base. Bronsted Lowry base NH3. Identify correct conjugate acid base pair. CO2, H2CO3, SO2, H2SO4, NH3, NH2 minus, HCl, Cl minus. Conjugate acid base pair. Conjugate acid base pair. HCl, Cl minus. Both C and D answer. Frequently asked question. Briefly explain the Bronsted-Lowry theory of acids and bases with example. What is conjugate acid base pair? Example with different examples. Briefly explain the Bronsted-Lowry theory of acids and bases with example. What is conjugate acid base pair? With examples. Thank you once again. In this hour, we discuss about Bronsted-Lowry acid, Bronsted-Lowry base, conjugate acid base pair, strength of acids and bases, and some examples of acids and bases.